Hello, welcome to the last episode of the objective questions on NECO 2023. 56, question number 56. A box contains 20 oranges, 14 of which are ripe and 6 are unripe. If 2 oranges are taken one after the other with replacement, meaning you take the first one, you note it, you put it back. Okay. We have to find the probability that one is ripe and the other is unripe. 2 oranges are taken. One is ripe, the other is unripe. It could be that the first orange taken is unripe. If it is unripe, it means the other will also be what? Ripe. It could also be that your first chance, by dipping your hand into the box, you are taking what? The ripe one. So it's going to be more or less like a compound probability, making use of the multiplication law and the addition law. So let's start. Let's denote the ripe oranges. For example, let's say S for total number of oranges in the box, and that will be 20. Let's use R to represent the ripe oranges, which will be 14. Then let's use N to represent unripe what? Oranges. So that will also be what? 6. So this is the information we get from the question. We are looking for a probability. So probability of ripe is going to be number of ripe oranges over total number of oranges. So this is going to be 14 out of 4. 20, which we know 2 is a common factor. 2 go there 7, 2 go here 10. Then let's also find the probability that the orange taken is unripe. So probability of the unripe orange is going to be number of unripe orange over total number of what? Oranges. With a common factor of what? 2. I'll be having 3 out of 4, 10. Alright. But we are looking for the instances whereby 2 balls oranges are taken. So it could mean that the first one is ripe, the second one is unripe. That is first and second. It could also mean that the first one is ripe, the second is what? Unripe. So that instance is there. So it means that we can find the probability of what? Ripe oranges, and which is the intersection of what? Probability of the unripe orange. This is what it means. The first one is ripe, the second is what? Unripe. Or, which is the union, probability of the unripe intersection, probability of what? Ripe. There are 2 instances we are having. So this is, the intersection is the multiplication. Then the union is the addition. So right here, probability of one ripe other unripe is just going to be the probability of ripe, which we already know as what? 7 out of 10, which is this, and is a multiplication. Then we are going for unripe, which will be 3 out of 10. We know the union is addition. Then unripe probability, which is still 3 out of 10, times the ripe probability, which will be what? 7 out of 4, 10. We know we only multiply the numerators if there is no common factor. So 21, then the denominators 100 plus numerators 21, denominators 100. Since this become a like fractions, we only compute the numerator. 21 plus 21, that will be 42 divided by 100. It is still the same denominator. And I believe there is a common factor of 2. So 2 will go here, 21, 2 go here, 50. So the probability of one being ripe, of taking 2 oranges, one being ripe, the other being what? Unripe, is going to be 21 out of 4, 50. And that will be the option C. on the question paper. So question 57, the mean of the set of numbers 2, 5, x, and 6 is 4. So what is the value of what? X. We know if you are looking for mean, we know the mean, let me write it this way, which is x prime is just equals to the summation of the x over number of what? X, meaning how many elements are present. And in this case, the mean has been given to us as 4. You see, the mean of this number is 4. So the mean is 4. Then we add the numbers divided by how many they are. So that means 4 is equals to 2 plus 5 plus x plus 6, all divided by what? 4. 1, 2, 3, 4. There are 4 items out there. Per this 7 plus this will be 13. So we have 4 equals to 13 plus x over 4. And I believe we can cross multiply here to have 4 times 4 to be 16 equals to 13 plus what? X. We are looking for the x, so we subtract 13 from both sides. So 16 minus 13 equals to x. That simply means x is just what? 3. The value of x in this series of numbers that will produce a mean of 4 will just be what? 3. And on the options, that will be E, the option E. In 58, we are to evaluate the integral of 2x minus x squared dx, the limit of 0 to what? 2. So what do we do? This is a definite integral. So what do we do? We are going to integrate by keeping, okay, let me write the integral first. Integral from 0 to 2, 2x minus x squared dx. We know our integration, we only increase the power of the variable by 1 and divide by the result. So I will increase this power by 1. It's already having the power of 1. If you increase it by 1, it becomes 2. There's a power of 2. If you increase by 1, it becomes what? 3. So this is going to be 2x squared divided by the same power minus x cubed divided by what? The same power. Then our limit of integration is still added. So here I can see that 2 will cancel. So I'll be left with x squared minus x to the power 3 out of 3, limit of 0 to where? 2. So now we substitute the limit into the variable x. So here I'll be having 2 squared, as in this case, this 2 is the one I'm placing in place of x. The square is already there. Then minus 2 to the power 3, which is this 2, power 3, divided by what? 3. Minus the 0 being placed here, and here will by all means give us 0. So no need introducing the substitution for the 0 or the lower limit. So this is going to be 4 minus 8 divided by what? 3. Have your denominator of 1, making this to be 3, meaning I'll be multiplying both the numerator and the denominator by 3. So 3 here, 12. 3 here, 3. Minus 8 out of 3. So that I have the same denominators. I only subtract the numerators. And I believe 12 minus 8 will be 4, right? Then we pick our denominator of 4, 3. We can see that 3 is less than 4. So it goes there 1. Remember 1 out of 4, 3. So the integral, the definite integral of this is just one whole number, 1 out of 3. And that will be the option C. Alright. Share this video with those that may need it. Like and comment. Subscribe if you are new to the channel. Bye-bye.